Hey, I'm a real boy. Excuse me. Jordan, Irby, Lucas. I need eyes and ears over here. Lay, focus, please. AJ, Gary. All right. Look. So this is the foundational piece to help us be successful, and I need us to note these details right here. Okay. So these are the conversations that I was starting to have with the different groups. And so first thing I want to point out, I want to draw on, is something that I heard Kyla talking about up here. So first things first, Kyla, you noticed, or your conjecture was, hey, if it's a positive slope, right, and a positive slope, then that parabola is going to be concave up. So first off, those positive slope lines, do they have a concave up parabola? Yeah, very much so. So when I had two positives, that parabola is concave up. Cool. We see it here, concave up parabola. But what if it's one positive and one negative? Is it concave down? Okay, that's pretty concave down, isn't it? What if we have two negatives? Again, when there's two negatives, it was concave. Concave.
Oh yeah, because they make it positive.
Yeah, I was saying, because what's a negative times a negative? A positive. Now, this is what it needs to really focus on. Mar. Put them up. Okay, but here's the thing, and I need y'all to hear me on this. The idea of concavity like this, it only helps when you're dealing with parabolas, with quadratics, which are x squared. We're about to go beyond x squared. What's after x squared? X cubed. No, you can do y squared, but no. So, after x squared is x cubed. And so we need to go beyond just seeing the slopes. And I'm really glad that you saw that pattern, because that can be very helpful. So for example, if I were to give you this function, would this parabola be concave up or concave down? You good? Guys, would this parabola be concave up or concave down? Why is it down? Hey, focus please. Would this parabola be concave up or concave down?
Down.
Down? Why?
Why is it a negative?
I see a negative and a positive.
Negative and positive what though?
-2 and a
So
negative
would this
3.
be concave up or concave down?
Oh.
It'd be down, it's too positive now.
Well, it's two positives, I thought that would be up. But see, hold on, so listen, y'all are being very vague with this. You say it, they, well, like what do you mean by that? What did Kylo point out has to be true for it to be concave, for the parabola to be concave up? The what has to be positive?
The lines. No, I forgot what.
The what? It's all about the slope, because we got to pay attention.
Oh.
Right here, these lines, are these outputs positive or negative for these lines? Negative. Over here, the values are... So a line is not positive or negative. The slope is positive or negative, right? And when both slopes were negative, the parabola was concave up. This slope would be... This slope would be positive. So negative slope, positive slope. So that's negative overall. That's going to be concave down. So it's important to notice slope. That's going to be helpful later. But when we go past quadratics, that's not what we want to look at. So here's the conversation I started having with people. Okay. Looking to the left of this vertical dashed line, we need to recognize, at least for this function, the parabola, are those values positive or negative? They're positive. Just to the left of, and by the way, why did I put a vertical dashed line right here? That's another way to say that.
What you call that? I'm on the point of inflection.
The point where the line goes through the x-axis or the curve, the x-intercepts. Right, that's right. Because wherever the line has an x-intercept, that's where the parabola will have an x-intercept. We've seen that pattern, right? And so when I look to the left of that x-intercept, the parabola had what type of values? Positive. The two lines, though, have what type of values? Negatives. And so Lucas, you said this earlier, they what? They multiply each other. Notice right there, Lucas and his group even wrote it out without me having to tell them, because I talked about it a little bit more with other groups. What's a negative times a negative? Oh, that's right. So this negative times this negative is a positive. Okay? Now, I'm actually going to continue building this conversation off of this graph right here, but I want us to see in between these two x-intercepts, right? The parabola, does it have positive or negative values? Negative. How do we know it's negative? Because I've heard some people say it's both.
I feel like it's negative.
It's below the x-axis. Remember, when we say values, we're talking about those outputs. Why are these negative when these were positive?
Because one of,
Well, you're right about just the parabola, but I'm talking about why are these below the x-axis?
because one of the roots is positive and the other one is negative. Right?
Not the roots, though, because the roots are here. One of the... I think I know what you... They're both positive slopes. Did you mean to say factors, perchance? No?
I did.
Not sure? Let me point this out. This is a factor. This is the linear factor. Are these values positive or negative?
Positive.
Positive. This is a linear factor. Are those values positive or negative?
Negative.
What's a positive times a negative?
Negative.
Oh, and the parabola is what right here?
Negative.
Negative. So, what I made a note of with this group here is I said, hey, the values, which when I say values, what do I mean? Output. So the outputs of one factor times the outputs of the other factor. That's what we've seen so far. A positive times a negative is, oh, and I should say that this is my quadratic or dilated function. Okay? And so when I look finally past this last x-intercept, what type of values does this line have? They're positive. AJ, what about this line? What type of values does it have? Sounds like they're telling you something. Okay, did you want to help them out about why? Do you know why they're saying positive, AJ? Because it's what? It's going up. And it's not just that it's going up, because technically it's going up here, isn't it? So why is it positive over here?
That's what I'm saying. So look, in that quadrant, get up. I can get up there. It's all right. Because look, up here, I'm the SX, these positive.
Now, is it about the x-axis though? Well, it kind of is. It's above the x-axis. And if we have stuff above the x-axis, the y values are positive, okay? Does that make sense, AJ? Above the x-axis, so those values are positive. And what's a positive times a positive? And so this parabola is all what?
Positive.
Now, I want to actually pause and I want to point this out really quickly. Hey, y'all, right here. I need us to see this really quickly. Because what I really should have done earlier is pointed out, what is h of x? How are we calculating h of x in the calculator? Say again. Look at the calculator over on the my right, your left. It's f of x times. Oh, so what are we literally doing with those two functions? We are. Oh, you mean like we were multiplying the positives and negatives here? And so it's not even just random multiplication. I need y'all to see this. F of x, is that my input or my output? F of x is the output, right? G of x is the
Input?
That's also the output. Remember, x is the input, f of x, g of x, h of x, those are all outputs. And so I want to get even more clear with this. Right here, AJ, can you hit the lights for me? Not pick up your phone. We've got 5 minutes left. At this input of -2, what's the output value? Okay, what's this output value? And hey, really quickly, what's -1 times -3? So if I look at x is -2, what's my y value for the parabola? 3. So it's not just positives and negatives. It's quite literally multiplying the y values. I'm multiplying those two sets of outputs. And if I take a linear and I multiply by a linear, I get a quadratic. We're going to go more into this in a second, But let's look at this slide 9 here, okay? So when I look in between, right? At x of 1, what's my y value? At this x of 1, what's my y value? Negative 1. Gary, what's 3 times negative 1? Hey guys, I'll even let us end a little early, but I just stop moving around. Gary, what is it?
Negative 3.
Negative 3? Hey, what's the y value right here? It's also negative 3. So what's really happening to get h of x? We are multiplying the what? Outputs. So guys, if I have the linear factors graphed, all I have to do is figure out how to multiply their outputs. So, final example here. Actually, let's do it this way. Yeah, I got 2.5 minutes. Look, quick question. Do you know how to graph y equals negative 2x plus 3? Oh guys, come on. Y-intercept of 3, a slope of negative 2. That was a terrible line. Shh. Don't come at me. All right, there's negative 2x plus 3. Ish. Here's x plus 3. Those are 2 linear factors. What points do I know that this function will have based on those 2 linear factors? Can someone please mark one of those points for me? Come on, Kyla. You dropped something. Here you go, Kyla. Okay. Can you mark the other one for me really quickly? So, can I see that? So, Kyla marked these 2 x-intercepts, right? Like we did in Desmos, I personally am going to mark that line right here. So to the left of that x-intercept, should my parabola have positive or negative values?
Negative.
Why do you think positive, AJ? So to the left of this x-intercept right here. Not sure anymore? Why negative? So notice these values up here, are they positive or negative?
Negative.
They're up.
Positive.
And these are,
Negative.
and what's a positive times a?
Negative.
So just by understanding positives and negatives, I know that this is going to be negative here. What about these values in between? These are positive and?
Get out the way, Gary.
And what's a positive times a positive?
Gary, get out the way, boy.
And so it's got to come up here, and
Gary.
then what's a positive times a
Gary,
negative?
Snell, Gary, get out the way.
So we get a concave down parabola. Just by understanding positives and negatives. We're going to practice with this a whole lot more and extend it a little bit on Monday. But we're just multiplying positives and negatives.